How do you choose between in-memory and disk key-value stores? Imagine you need to quickly access data in your application, but you also want to keep everything safe and stored long-term. Deciding between in-memory and disk key-value stores can seem tricky at first, but it all comes down to what your project needs most. Let's break it down step by step. In-memory key-value stores keep all data in random access memory, which is the computer's short-term memory. Because memory access is so fast, these stores can handle thousands of read and write operations every second. This makes them perfect for situations where speed is everything. For example, if you're building a real-time gaming system or a website that needs to serve data instantly, an in-memory store is a great choice. But there's a catch. Memory is more expensive and limited in size. If your dataset is small enough to fit into your server's RAM, then in-memory storage can be very efficient. However, if your data grows beyond what your memory can hold, you might need to look at disk-based options. Disk key-value stores save data on hard drives or solid-state drives, which are slower to access but much cheaper and capable of storing large amounts of data. Durability is another big factor. In-memory stores are usually volatile, meaning if your system crashes, all data stored only in memory can be lost. Some in-memory stores add features like periodic snapshots or transaction logs to save data to disk, but it's not automatic. Disk-based key-value stores, on the other hand, write data directly to non-volatile storage, so your data stays safe even if the system restarts or crashes. If your application involves sensitive or critical data, durability might be the deciding factor. Think about your use case. If you need lightning-fast access to frequently used data, like caching user sessions or real-time analytics, an in-memory store such as Redis or Memcached is ideal. They conserve data in milliseconds, which keeps your application responsive. But if you're storing large product catalogs, logs, or user information that must be saved for a long time, disk-based stores like RocksDB or Berkeley Database are better suited. Some systems combine both approaches. For example, you might keep recent data in memory for quick access and periodically write it to disk for safekeeping. This hybrid approach offers a good balance of speed and durability. Cost is also important. Memory is more costly per gigabyte than disk storage. If your data volume is huge, maintaining enough RAM can become expensive. Disk storage scales more easily and economically, especially with cloud services that offer flexible storage options. Finally, consider how complex it is to manage each type. In-memory stores are simpler to set up and operate but requiring careful planning for data recovery. Disk-based stores are more mature and reliable but may involve more configuration and maintenance. In short, pick an in-memory key-value store when speed is your top priority, your data fits comfortably in RAM, and losing some data in a crash is acceptable or can be mitigated. Choose a disk-based store when you need to handle large amounts of data reliably and can accept slower access times. Many applications benefit from combining both, using in-memory for quick access and disk for long-term storage.